have James Waldrop here from Twitter. He tells me that he is an avid kayaker. He likes to kayak at night, mostly because his kids are sleeping then, which I can very much appreciate. I get to walk the dog somewhere around midnight, so that's something we definitely share in common. And even though I'm not going to explain to you why, if you want to go out to moderator, you should put this question in there about why is his product labeled Lotto. Because he loves this question. That's what I heard. So with that, James, come on up, and we're excited to hear about your talk, Testing Systems at Scale.
Thank you. Thanks, Tony. Let's see. Yes, the product. It's really an open source library. I try not to basically say too much about it, right? Except clearly at presentations like this. It's actually called Iago with an I. The font used for these presentations is sans serif, so please keep that in mind as you look at the name of it, because I constantly get questions about logo, and people who are clearly using sans serif fonts are looking at this going, okay, that's an L. It's not an L, it's an I. Yeah, anyway. So I joined Twitter about 2 years ago, a little more. And when I joined Twitter, my first week we had an outage where the site was not available to users. And the experience for the users was this. This is not a great experience for your user if you care about actually keeping your service up. Although it's an amusing picture, we love to, people love to make fun of it. Clearly, if you're an engineer who works at Twitter, this is a very sad face image. You do not want to have this showing up and your mother calling you and saying, hey, your system's down. So how do we get rid of the fail whale? In the last couple of years, we've gone a long way towards getting rid of it, and I'm basically going to talk about how we do that at Twitter. And specifically the fail whale, if anybody really wants to know the meaning of it, fail whale is a 502 HTTP response code. And if it takes more than 5 seconds to render your request or to respond to your request, then we will serve you a fail whale instead. And so that gives you an idea of exactly what's going on behind the scenes. When you see that, it's not a great story. So why the fail whale? I don't know if anybody, I'm sure there are quite a lot of Ruby advocates in the world and in this room. And a lot of the systems at Twitter famously were built on top of Ruby on Rails. I'm not going to say anything bad about Ruby. I will say, though, that when you have a monolithic architecture that has all been written in one big blob of code effectively, that it becomes very hard to effectively manage that code, both in terms of its performance and in terms of its ability to make changes to it. So the Ruby world has a lot of interesting ways to achieve performance these days at the scale that we care about. And unfortunately, we really couldn't do any of them because of our monolithic body of code that wasn't able to be iterated on in a reasonable way. So the answer to that, of course, was to decompose it. And so at this point, I think we have something along the order of about 120 services in production. So we've taken this monolithic body of code over the course of the last 2 years and turned it into a lot of little services which are written in many different languages, including many on the Java virtual machine, Java, Scala, Clojure, and then also some written in things like Python, C++, and still Ruby. But because we can, now that it's decomposed, we can make changes to it more quickly. Our engineering organization of, hey, I'm going to build this particular area of the product, and you're going to build this area over here, actually is able to work that way because they have their own service that they can deploy, and this guy over here has his own service that he can deploy. And so they can work relatively independently of each other. The problem with this, as anybody who's maybe gone through this, or if you think really fast, you might realize that there's an issue here, which is that as you move from this monolithic world to a service-oriented world, testing becomes a huge problem. because in order to test any given piece of software at a reasonable, to find out if it can handle production load, you need to be able to stand up that whole environment. And in the case of Twitter, and in the case of, for instance, the previous talk, Google, that's probably close to, if not impossible. And so how do we test in this new world? How do you test systems at scale when any one service might depend on 20 downstream services, and they in turn depend on another 20 downstream services? And in told, if you want to stand up any front-end environment, you're probably going to have to stand up 80 of those 120 or whatever number of services we have in production. Oh, sorry. So I'm going to talk about this. The rest of this talk will be about synthetic artificial load. Clearly, I wanted to give a kind of a front page shout out to all the other ways that we have to test performance. But I will say that all of them are in production. And I don't know about people in this room, but personally, I feel like if I'm testing it in production and my users can experience pain, or I can take the system down, let's say, in production, then that's probably too late to be testing it. And I really want to test it before any of that can happen. But the techniques that we have to test in production, as far as performance goes, are canaries. Canary, if you're not familiar with the concept, you have a cluster of systems that are handling requests, maybe 1,000 of them. You deploy your new version of the software to one of them, and now it's taking 1% of the traffic, and you get to see, hey, is it getting better or worse as compared to the old system? Clearly, though, it's taking production traffic. There's dark traffic. This is a little safer. It is basically a system, and we use this heavily at Twitter, we have a front end called TFE, funny name, right? TFE will take traffic, and then if it's configured in such a way as to do this, it will send part of the traffic it'll send all of the traffic to the normal production systems, and it'll send a second request to a system that's not stood up yet, and whose response it's going to throw away. All right, but now users aren't affected unless, for instance, this has happened, sadly. The system that it's sending the traffic to doesn't respond in a reasonable amount of time, and TFE isn't necessarily configured correctly in order to handle that. Let's say, pretend that this might not have happened 6 months ago. And lo and behold, you have an outage caused by dark traffic. And then the final one is more interesting to people who are doing functional testing. Tap compare is the ability to do a dark traffic read or a dark traffic write, like I just described, but compare the results and make sure that the software you're about to stand up actually sends the same content as the software that you have in production today. And with that said, I'm not going to talk any more about testing in production. Well, I will, but only in a scary, really inappropriate way, but it's fun. So what did I do? I joined, like I said, 2 years ago, and I was in the performance engineering group at Salesforce. I came to Twitter specifically to try to solve this problem as far as performance goes, and I wrote a load generator. My load generator internally is called Parrot. It turns out, though, that there are any number of trademarks associated with Parrot, including, most unfortunately, the Parrot VM that Perl 6 will run on someday. And when we open sourced it, I couldn't call it Parrot, so it's called Iago. I actually had no idea that Iago was this bird that you see up here. I'm too old to have seen Aladdin. I crowdsourced the name. I said, I can't call it Parrot, guys. What should I call it? A bunch of people wrote back, and the one that got the most votes was Iago. I'm like, Shakespeare? I don't get it. But okay, sure, it got a lot of votes. And then I found out it was Aladdin. So yeah. So why did I need to write a load generator? There are a lot of load generators out there. I've used I'm not going to say all of them, but I've used a lot of load generators in my lifetime. I've used JMeter, I've used LoadRunner, I've used AB, I've used Flood, I'm not going to go through the full list, but I've used a lot of them. So why did I feel like I needed to write a new load generator? First of all, a lot of code at Twitter is written in Scala. I wanted to learn Scala. I had written some toy projects in it. And so I was like, hey, wait, what's the best way to learn a language? You write some piece of code that you already know how to write in this new language. That'll be great. Sure, that's an awesome reason to invent a new load generator, right? Another reason is that, do you ever get this sort of thing, like if I'm not actually doing engineering, that the other engineers won't respect me? So it's like, if I just bring in JMeter or I bring in Load Runner and I start running load against their system, I'm not going to get nearly as much credit or respect in the organization as if I wrote my own, right? So, yeah. Another reason, hey, all those other load generators, sorry guys, you suck. There's really no reason to use any of them. They're all bad, right? Clearly. I hope the answer is obvious. None of the above. But when it comes to load generators, I have done this 3 times before I got to Twitter, and then I did it a 4th, and I open sourced it, so hopefully I never have to do it again. But I really want load generation to be simple. And I have a lot of experience when it's not simple of what happens. And what happens is that you end up with very large performance engineering teams, and they're very hard to hire onto. It's a very specialized skill. And so you're sitting there constantly like trying to scramble and figure out, is it going to scale? Is it going to scale? And you don't have enough people to answer the question why, or what if it will. And you don't have enough people to answer the question why won't it when it doesn't. So if you're an engineer, as I've been, and you want to answer this question, will my new service, new whatever feature, thing, gizmo that I'm about to ship to production, is it going to scale? Can it handle 1 million QPS? How do you go out and do that? You sit down in front of your computer, you're an engineer, and guess what? You write a for loop, right? So a for loop, if anybody's not ever written one, I really hope that all of you have, sits there and you write a for loop. Let's see, I think I have a piece of, yep, there we go. So that's a for loop. We're going to start up 100 threads and we're going to make requests as fast as we can against whatever service it is that we have stood up. And apologies, this was not code reviewed, so it may not be actually compiling, but it's my sort of theoretical abstract for loop. And any load generator that you're going to use had probably be able to be better than this. If it's not better than this, then the engineer is just going to sit down and they're going to do it themselves because this takes 5 minutes to write, if that. So that is, if you're writing a load generator or you're going to be, if you're in that business, you had better outperform the for loop. Unfortunately, though, at least if you're an engineer, the for loop is really appealing. If you're, say, JMeter, and all of your configuration is either via XML if you want to do it that way, which most people don't, or it's a GUI that looks like it beamed in from the late 80s. If you're load runner, it's a GUI that happens to be really unstable and can't do automated testing at all. Or if you're AB, it's something that's completely not configurable at all. And if I'm sorry to bash on JMeter, I'm sure a lot of people here have used it. It takes forever to actually write a load test in JMeter. And if you want to do anything interesting at all, you're going to be writing a plugin, and I have done that, and let me tell you, I do not wish it on anybody. It would be really nice if whatever this load generator was really easy to write new things in. It has to be extensible. For loop actually satisfies all of those constraints. But the for loop has a problem. It turns out that it's actually quite wrong as far as testing performance of your code. It will give you nice, warm, fuzzy answers of, I can handle 40,000 QPS. Woohoo, look at me and my product and my service. It scales really well. But it turns out that has nothing to do with what's actually going to happen to it when you get into production. Why is that? So let me talk about some systems theory. Sorry to be academic for a second. Does anybody here know Little's Law? Raise your hand if you know Little's Law. Awesome. Nobody here knows Little's Law. I'm glad I put the slide in. So Little's Law is a really awesome mathematical result in queuing theory that says that if you have a service and requests are arriving at a particular rate, that the number of concurrent users or concurrent requests that service will be able to handle can be found by saying what is the request rate and what is the latency or what is the time it takes to service that particular request. And that might sound intuitive, and it is. If you think about it, like, hey, if I have 100 requests a second and it takes a second to satisfy that request, then I will have 100 requests concurrently, right? It's simple math. But it turns out that the math behind that is actually pretty hard to derive, and it's awesome that it's such a simple result. But really it's just math, so why do we care? What does Little's Law have to do with a for loop? Well, if you are a performance engineer, you very much want to change one thing at a time about your system so that you can know for sure that the performance impact that you are experiencing is because of that change, right? Flaky tests were mentioned earlier. Flaky tests are the bane of performance engineers because you never get one answer. You always get a range of answers whenever you run these tests. And so it's really important that you be able to change something, try it again, change something, try it again, and get results that you can count on. But Little's Law actually makes that very hard to do that on a system which is specified in terms of concurrent users. So open versus closed systems. Basically, an open system, and again, I'm not talking about open source or any of the open, like APIs and or anything like that. This is systems theory. An open system is a system where requests can arrive independent of your ability to service them. So in other words, an open system is what you get when you put your service on the internet, where your users, as much as you wish they would, do not care that you're slow right now or that there's a big spike or that Michael Jackson just died. They're going to send you requests, whether that's tweets or trying to read tweets, regardless of your ability to actually handle them. A closed system is much nicer to model. It's one where it's like, if you can imagine, probably the best example I can think of is a call center, right? Where you sit there on the phone with the poor person who's sitting in front of the computer. There are only 500 agents, so that's the concurrency right there, 500. And they sit there and say, I'm sorry, the system is slow right now. I'm waiting for your data to load. That's a closed system. It's awesome because you can just say, all right, I need to be able to send 500 threads. JMeter can model that quite well. But in the real world, we model things with requests per second. So in that concurrency is equal to latency times request rate, we need to model request rate, not concurrency. So one more thing. JMeter and almost every other load generator I've used, by default, will speak HTTP, which is fine if you have a web service. Clearly, Twitter is a web service, so why isn't that sufficient? Well, it turns out that when you build a big service-oriented architecture, you're probably not speaking HTTP on the back end. At Twitter, we're talking Thrift. Thrift is a wire format that is similar to protobuf, which many of you are probably familiar with if you're not familiar with Thrift. And you have to be able to talk Thrift if you're going to be able to test systems in isolation. Because you can't stand, like I said, you can't stand up the whole service of Twitter, all 120 of them, and then send some HTTP requests in order to make something happen way down, 10 systems deep, so that you can find out whether or not you can handle the load, right? So you need to really be able to test components, not test the whole system. Supporting Thrift is really, really tricky. It turns out that in Thrift, you actually you code gen your protocol, and you typically do that at compile time. So when you're building your system, you have bound it to a particular RPC by the act of building it. And that means then that all of your data objects are there at compile time. And if you're imagining a world like JMeter, then it means that my load generator is suddenly going to have to know not only your protocol, right, which is tricky in and of itself, but also going to have all of your code gen stuff, which means that if you think about it, there's 120 systems at Twitter, so that means that now my load generator code is dependent on all 120 Thrift interfaces that they expose, and I open sourced it, so now it's dependent on anything anybody can ever do, which is clearly impossible. So I had to change the mental model of how this works in order to satisfy that need to support Thrift. HTTP, you don't have any of those problems. HTTP is a very well-defined protocol, cookies, headers, posts, different kinds of requests, but very well specified. And nobody's going to, other than HTTP 2.0, nobody's going to invent a new kind of HTTP that you need to support in order to make your load generator work. But Thrift is a lot harder. So I had to flip the model in terms of the load generator. So in the JMeter and any other system you might use world, the dependency is on the system. Instead, I flipped that, and the dependency now goes from the system to the load generation library. And so when I got up here, I talked about the fact that Iago is a library. It's not a product per se. It is a load-generating library. You depend on it just like you depend on any artifact. And what it gives you is enough stuff that allows you to write to an interface, which allows you to implement your particular load test. And I'll show you some examples here in a minute. And you write to that interface, and then you launch it, and it ships. With that dependency comes enough, jar, blah, 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 comes along and then allows you to launch it. It comes with effectively an execution environment along with it. Secondly, so not only is Iago different in that it flips the dependency model on its head, it also uses Finagle. If anybody has used Finagle, then you're probably like, yay, cool, Finagle's awesome. I'm assuming that's not most of you. Finagle is a Scala library that we use heavily at Twitter. It's open sourced. We wrote it, and a lot of people are using it. And it allows us to do asynchronous RPCs over Thrift or HTTP, or really name your protocol. MySQL was recently added, and we have a Google Summer of Code. Shout out to the folks who organized that. Google Summer of Code project this year for adding Zookeeper support, for instance. Chances are that if it doesn't support what you need to do, it probably will be there or is easy to write. Finagle, because it's asynchronous, solves our open system versus closed system conundrum that I described earlier. In an asynchronous world where you have, it's based on Netty, so if which is in turn based on Java NIO. So if you have an async world like that, you can basically say, hey, I needed a request to arrive every millisecond. Let's say that my arrival rate is 1,000 RPS. So I needed a request to arrive roughly, if I had a uniform distribution, every millisecond. Okay, great. I'm going to send a request every millisecond. I'm not going to have a thread per request. I'm not going to care how slow or fast your system is. A request will be sent and will arrive every millisecond. If your system is down, then I'm going to get connection refused. If your system is up but slow, then there's going to be a socket held open for a certain amount of time. But the resource constraints on my test system are not going to interact with the resource constraints or the problems that you might have on your service. That kind of coupling is death to a performance test. If you get your system under test coupled with your load generator, then you've created a closed system and you're no longer modeling reality, at least modeling reality for most of us here. There may be, clearly I described a case where somebody could create a closed system, but for the most part I believe everybody here probably works at internet scale, and therefore you are all needing to model open systems, and so you need something where it's going to generate those requests regardless of how slow or fast the service is at this particular build. So that's all cool, but what's it mean? So I mentioned that I'm going to get to some code. I'm actually moving faster than I expected. Maybe I should slow down. So we'll have a lot of time to look at the code. But there are some implications about this model of, hey, here's a library, you depend on it, you write your load test using this library, and then you just launch it and it runs and it's all good. For me, the most important thing, I came from a team at my last company where there were, when I left, I think there were 15 performance engineers. And now I've heard that the team has, over the last 2 years and change, the team is now something like 50 performance engineers. And their job is to write performance tests. And that's what they do. And in order, as the engineering team grows there, they have to hire more performance engineers, right, in order to performance test all the stuff. I think that model is very hard to make successful, especially when I started at Twitter. The company was quite a bit smaller. I think there were roughly 200 engineers at Twitter when I started. I wasn't going to be able to go and performance test every single person's thing. They were all moving really fast, way faster than I could move just by myself. And I wasn't going to go out and hire another 19 performance engineers really quick and say, okay, great, now we can performance engineer. Now we're going to be able to test your stuff. And oh, by the way, today we're something like 900 engineers, which is the size of actually just Google's test team, but never mind. So, now I would need 90 performance engineers, or whatever the ratio is, right? Let's say it's 5%, then I'd need 45 or so And you can project out to infinity and realize that, in fact, this is probably not going to scale because there aren't that many performance engineers on the planet, right? And so it's really important to me that if you're an engineer and you're building a service, that you be able to write your own performance test. Not that you can go and learn JMeter, not that I force you to go and, God forbid, use load runner, but that you actually can just write some code like you would write your for loop, and write your own performance tests. So that's a clear implication of this dependency model switch, is that you're no longer working in a world where most of the domain expertise is something that's unfamiliar to you. You're working in a world where it's your service. You probably already wrote a sample client when you wrote your service, and you just use that same code to generate the load test. It's very simple, similar to how the for loop is very simple. I have been at, like I said, I've been at Twitter for 2 years. I've written 2 load tests the entire time that I was at Twitter. I spent the first 6 months writing the load generator. I wrote a couple sample load tests that were actually never run. People looked at it and said, oh, this is easy. I'll just do this myself, and I never actually ran those. And there were 2 instances where I had to do a load test because they were testing some aspect of the system where there either, in one case, no team existed that was maintaining that system, and yet we were expecting it to get a large burst in traffic. And in another case, it was crossing so many organizational groups. This was the most recent example. I had to test for New Year's Eve. And so I wrote that test of what happens when 30,000 Japanese people all tweet at midnight. Exactly, right? It's the best distributed denial of service attack you've ever seen. And so those are the 2 load tests that I had to write. I'm going to show you one of them. I don't think I have time to show you both, but I'll show you the most complicated one so you get some sense of exactly how hairy can it get, and I'll talk about that in a second. There are some unintentional things that happened as a result of doing it in this way. It turns out, I mentioned that you have sample code already written. It turns out that you actually have to write a lot less code. When I write a JMeter plugin, there is a ton of boilerplate that I have to implement. In other systems, I have to write a whole bunch of stuff just to get it to do what I want. Iago, the code you're writing is the code you already have, so you probably are just copying and pasting it in the worst case, or pulling it in as a dependency in a better case. And so you just don't have to write as much code. It really takes people, literally, you might think I'm exaggerating, but it typically takes an engineer at Twitter who has never been exposed to the load generator before, and everybody now at this point, I believe, well, except the 50 or so we hire every month, will have been exposed to it, but it takes them about 30 minutes typically from, I don't have anything, my manager just told me I should probably find out if this is going to scale, to, all right, here, I've got a load test, and I've run it, and I found out that, in fact, it doesn't scale at all. Oh, shoot, I have to go back to the drawing board. Or, better case, it's awesome. It also has another really fascinating implication that I'm going to get to here in more detail in a second. But it means, with Finagle makes it really easy for you to think in terms of asynchronous operations. It has this concept of a future. Hopefully many of you are familiar with that from the Java world. The future signature in Scala is a little nicer and easier to work with than it is in Java. And it allows you to compose RPCs in a way that lets you say things like, first I need to authenticate this user, then I need to check and see what if they have the right access, then I need to run this request against this backend service, and I'm going to scatter gather, so I'm going to run this request out to 100 different services, and I'm going to compile the results, and I'm going to throw away the ones that didn't come back in a certain amount of time, and then I'm going to collate that into a response that I send to the user, and I can do all that in about 3 lines of code. So Finagle makes it really easy to compose really complicated RPCs. Using that in the load generator in turn means that you can write really complicated load tests really easily. And I didn't expect that at all because I had never been exposed to Finagle, and that was a really nice result. The thing that means is that, as you're going to see, it means that you can write very complicated functional test scenarios that normally, before I had a tool like this, the way that I would do performance testing and make sure that the service is behaving correctly at the same time, let me describe a scenario where this isn't done. Let's say that you have a load test and you're running it and your service is performing really well. And then later somebody has the bright idea to go and look and see what's actually happening. And what's happening is, hey, it's amazing. The performance is awesome. It's really, really good at serving a 404. right? Or it's really, really good at serving a 500 because there's an exception, and it turns out that an HTTP 200 with a nice graphic like a fail whale might, to your load generator, look like success, but in fact, the right thing isn't happening at all. Well, how do you solve that problem? Well, of course, then your load generator needs to, hopefully pay attention to more than just the response code. But also, you might think that this is the way I solved it in my last gig. You run your load, and you're running a functional test beside it, right? And you're like, OK, under this amount of load, these scenarios still operate correctly. And so here I've got JMeter, let's say, running against the service, and I've got a Selenium test or a WebDriver test running simultaneously. And that's fine as far as it goes, but wouldn't it be nice if you could actually say 100,000 users can all do this at the same time, or they can do these 50 different things all at the same time? And it turns out honestly, I don't know of any way to do that other than this load generator, Iago. So, right, I didn't have to load test 100 services, so I had a lot of time to dedicate to making Iago great. It's still not as great as it could be. We are in the process of syncing out a bunch of stuff to the open source repo, bug fixes and such, but I would really, if people are inspired by this talk, feel free to come and make contributions. Unintentionally, the idea of having a service which is really solid became the model for how we do all of what I call developer productivity, or probably a lot of you. It's not a realization I had alone, but we basically are focused. I manage a team now focused on developer productivity, and our build system works this way. The test frameworks that we support works this way. Our test infrastructure setup works this way. Our deployment tool works this way. And so it became a model for how things should work, is that give engineers great tools that are really easy to use, where the default is almost easier than it's almost easier to use them than to not use them, and they will do the right thing. And so that's how we're doing things at Twitter, which hopefully is no surprise to anybody. All right, now we get into the meat. Hopefully you can all read that. I actually don't care if you can't read that too much, because it turns out that this is just an example of how to write an echo service in Finagle using Thrift. So you can imagine that you would have a service like this. It takes a method, or it has an RPC that says echo, and then it's going to reply back with what you wrote. That's just, I'm trying to be relatively open kimono here. There's no hidden dependencies, or other than on Finagle and things like that. But there's no hidden code here. That's really how the service is written. I cut it off at the end because below that is all the Zookeeper discovery business, and I figured people don't care. Here's the client. I mentioned, I hope anybody who's writing a service has probably also written a client for it. If you haven't, then you should probably think about doing that, because you learn a lot of interesting things when you behave like your customer, whoever that is. But here is a client that is going to send the message hello. And when it gets the response back, it's going to print something out and say, all right, I got a hello back, right? And that's how you write that code using Finagle, talking to my echo service. And it's not a lot of code, right? There's a lot of noise in there about types, but other than that, it's pretty self-explanatory. And by the way, if anybody here doesn't know Scala and you're totally confused, my apologies. Here is a load test. I'm going to jump back and, all right, take a look at that for a second. Notice that it's calling client.echo, right? I'm going to go back. Client.echo, right? So if you see that, it's actually the same code. And in fact, it turns out it's less code. How is that possible? How could it be less code? Well, it turns out that Iago takes care of some of the boilerplate as far as connecting to a service goes. So this load test actually does a little more than the sample client. It actually, if it gets a hello back, then it sends another message and logs it, right? So that's a really simple example. I'm going to get into a more complicated example here in a second. It turns out that if I wanted to write a for loop that just sent echo requests asynchronously, as long as I knew enough about Java NIO or Netty or some other library like that, it would be really simple for me to do that without too much effort. Great, what have I gotten? How can I do better? So we have more complicated problems than that, it turns out, at Twitter, and hopefully most of you as well. So load testing direct messages. Direct messages are a feature in Twitter where you can send a private message from one user to another as long as there's a following relationship between them, with some exceptions that I'm not going to go into related to brands, where they'll allow you can direct message them without them following you. I didn't put any of this in the slides because I was worried that comms would come after me. So I will talk about this rather than I have to get slides approved. So nothing that I'm going to tell you is confidential per se, but at any rate, we had a TV show, one of these reality game shows similar to, say, American Idol, where people are singing, they get up on stage, they sing, you vote, and then America picks the winner, right? They go home with hopefully a nice recording contract that doesn't take too much of their money. One of these such shows wanted to use Twitter to do the voting. And this show had a $5 million prize at the end. And they were going to do the voting every single live show over Twitter and include those votes along with everything else. But in order, voting online has to be private, at least without some major exceptions. And so they were going to use DMs. And at the time, and I'm not specifically not, in order to not get myself in trouble, I'm not talking about when this was, but at the time, we were getting roughly 400 DMs a second over our system. So 400 messages a second back and forth that were of this type. And when you figure out that most of the TV showing happens in the East Coast and Central together, which is most of the population of the United States, and that all of this voting would be happening at the same time because the polls open, as it were, at the end of the show, and so everybody immediately goes and they do their voting. So you get a flood of traffic. We figured out that we were going to have roughly on the order of 2,000 to 3,000 DMs per second. And as I said, the production traffic at the time was 400. And so it was clearly we were going to have a large increase over what we could handle. So we needed to be able to test that. This is a direct message. Again, I'm going to show some code, and actually I'm going to go a little quickly because I have about 4 minutes, but I'm not going to go super quickly. That's just a underlying type that would hold a direct message. Here's my processor. You might actually be able to figure out from the code what the TV show is. We're actually going to show a lot of this, like 5, I think, slides of code here. So don't get too attached to any one piece of it. This is happening up in the constructor. There is an eval, and then we pull in a config, and then there's a couple of URLs. This is using our API 1.0 endpoint instead of our API 1.1 endpoint. This code was written long enough ago that there wasn't a 1.1 endpoint. And by the way, none of it has been code reviewed, so please, my apologies. I know it's not the highest quality code. I wrote it in literally like a day. So there you go. Here's some stuff. It turns out that if you're going to have $5 million riding on the votes, that you had better get them right. You better not drop any votes on the floor. You better not have votes show up for people you didn't expect. And so the voting, like in my load test, when I talk about being able to test correctness and load at the same time, it turns out to be critical in this case. Because I need to be able to make sure that of those 3,000 DMs per second, or whatever the number is that I'm going to test at, that all of them show up for the right guy, right, or girl, or whoever it is, and that like I said, that none of them get dropped on the floor or arrive out of order is fine in this case. So I need to track a bunch of stuff. It also turns out that I don't have a system, another system like Twitter that's not Twitter. Right? I don't have a copy of Twitter in my back pocket that I can just stand up and run a bunch of tests against because that would be expensive and it probably wouldn't fit. So I need to use Twitter in order to run this test, which means I run the risk of knocking over production, as it turns out. But anyway, that was a known risk. But it also turns out that I don't have millions of users in my back pocket, and I can't go create millions of users because it would throw off our analytics, and our growth team would get really excited, and I would have to break the news to them that was just me. And so I don't have a million users in my back pocket, so I decided, you know what, it doesn't matter. I did a lot of talking to other engineers. This was pretty shortly after I arrived at Twitter. I didn't know much of the system at that point. So I talked to a lot of people, and they said, no, it probably doesn't matter. You can probably send all these DMs from one account. So I sent all the DMs from myself. literally, I use my own account. But it turns out that we have rate limiting at Twitter. And so if I need to send 3,000 DMs a second, if any of you want to do this, you're going to get stopped almost immediately. All right? But it turns out that my load generator is running in production. And so it has access to memcache, which means it has access to the rate limit. Right? It has access to my rate limit token, and I can go and reset it as part of my load test. So the load test is sitting there DMing, and meanwhile it's also talking to memcache saying, that guy, no, we're going to zero out his rate limit again, all the time, over and over and over again, quite rapidly. And I mentioned that I want to make sure we don't drop these on the floor. Our customer was using our streaming API, which internally we call Hosebird, and so I wanted to make sure that I was getting the same data that they would be. So I make a connection to Hosebird. So there's my connection to memcache, right? There's my connection to Hosebird. I elided the connect to Hosebird code because it's not that interesting. And then here's my load test. So I need to pick a particular host to hit. I need to decide what I'm going to send. So I have a vote randomizer function that I'm going to call. I need to set up the request. I'm going to make a URI out of that. I'm going to set the OAuth header with all the right correct authentication codes. And I'm going to make a Iago/parrot request with all of those parameters. And then I'm going to map that onto my request, call my service, which is that second line up there. And when the response comes back, I'm going to decode it and check to make sure that I haven't exceeded my DM limits, and if so, reset them. And then I'm going to look and see if I got a decent response back, meaning it's some HTTP response as opposed to an exception that I got on the wire. Then I'm going to read that DM, and I'm going to do some check for missing DMs at the end. Right? It's very simple logic. It turns out that this logic actually had a bug. It's kind of funny. I think anyway. You'll see. The way I wrote it originally was, all right, I'm going to send a message, and when you send a DM or anything on Twitter, you get back, when you create something, you get back an ID. So I'm going to get back the ID in the response, and I'm going to be waiting over here for the stream to give me a DM with that ID, right? And I found out that we were dropping tons and tons of DMs on the floor. This is horrible, right? It's not working at all. What's the problem? It turns out that Hosebird was delivering the DM before I actually got the response back. So our streaming API is fast enough that it will send the DM down before you even know what the ID was, right? And so I had to create DMs that have unique text in them just so that I could match them up, because I was going to get them on the streaming side before I got the response. It's an awesome bug. Yeah, that's all the code. That's it. That's how you test DMs. What do I want you to take away from this? So clearly, most of you, some of you, I don't know how many people from Google are here. Google clearly deals in more scale than we do, as does Facebook and a number of other sites. But in general, most of the world doesn't handle the amount of test load that we have at Twitter. Just to give you an example, when I went into this, one of the things that I wanted to be able to do was to be able to generate a lot of load. I had run into scalability problems with JMeter and systems like, where they have very simple request response patterns, meaning, give me a counter. Great, I got a counter back. You can be very fast at that. And 40,000 QPS was a lot for JMeter to handle. And I knew that Twitter handled more than that when I came to the company. So I wanted something that could scale really well. And I had in my head that, 100,000 RPS would be cool. That'd be awesome. And one day somebody needed that much, and we were able to do it, and it was no big deal. And then somebody else came along, and they wanted 500,000 QPS. And I was like, oh, wow, that's a large number. Okay, let's see. I had to tune a couple things, and then we did that. And then I haven't touched the code, honestly, in 6 months. And a month ago, I was idly sitting, lunchtime conversation, and I hear behind me, 2 million QPS, we tested, and I turn around, I'm like, what, 2 million, who, what, really? And I was like, you didn't do that with our stuff, so how did you generate 2 million QPS? That's awesome, I want to know what did that. Turns out, you can generate 2 million QPS. That is almost an afterthought versus everything else that you get to do with this. Pretty interesting as far as Twitter's problems go. It turns out that you probably all should want your engineers to be writing their own load tests instead of doing it yourself. And you should also clearly want your load tests to be accurate and model the real world. There you go. I have all of 1 minute so for questions, and I'll be available for lunch.
Great, thank you, James. I got my takeaways again this time. One is I learned you were a optimist and not a pessimist. All your for loops had starts but no ends.
Yeah, thanks.
And I also learned I have to go learn Scala, and somehow somebody slipped in like a next generation Lisp somewhere in the world. So Scala is it. I also know Foursquare does Scala, so
Yep.
it's growing in popularity. We are going to take a break here in a minute. I think we have time for one question if we want to go to the mics. So if you have a question, go to the mic. Otherwise, we'll take one off the moderator. Then we're going to take a break. Then we're going to come back here exactly at 11:30. And we're going to go into the next set of presentations that will be done by Mozilla. And right before this question, two things. Some people have been asking if the slides will be posted. Yes, they will be posted. And so will the video and the content and all these questions and everything after the talks. So they will definitely be out there. And number two, there's a lot of people standing up in the back of the room, just some to stretch their legs, but there's also people that like a seat. So when you come back from the break, kind of squish into the middle as much as you can. So with that, we'll go to a question.
I like the top one.
All right, so here's the first question. It says, does Iago allow clients in languages other than Scala? In other words, can developers port their clients in other languages to write performance tests?
Yeah, so sorry, can you hear me? All right, so Scala is a JVM language, which means that those libraries are available to any other JVM language, which means that as long as you have code written for the JVM, and that can include things like Jython or JRuby for that matter. So really, anything that you write on the Java stack for, you can use Iago.
Great. Awesome.
Cool. Thanks.
All right, with that, let's go ahead and take our break, and we will be back at 11:30.